Hello dear students, I am Professor Mandar Dixit from Electrical Engineering Department. Today we will see one more problem based on supernode. The problem is like this: obtain current through 15 ohm resistance by nodal analysis. This question was asked in Mumbai University question paper of December 2016 for BW. The circuit diagram of the problem is like this. Now if you see this and this, these are two nodes. In between these two nodes, a 45 volt battery or a 45 volt DC source is connected in between these two nodes. Hence, we have identified that this numerical has to be solved on basis of supernode concept. The first step is to mark the different nodes in the circuit and unknown currents in the circuit, and we will modify the circuit. Let us mark the node. Let this node will be node number 1. Let this node will be node number 2, node number 3, and in the numerical the reference node is already indicated. So we will take same node as a reference node which is connected to ground. As 45 volt battery source is connected between node 1 and 2, these two nodes will act as a supernode. Hence, this portion or these two nodes will be considered as supernode. Now, excluding supernode, we will indicate the unknown currents in the circuit. This is I1, this is I2, this is I3, this is I4, and this is I5. Now for supernode, if you observe that the battery negative terminal is connected to node 1 and battery positive terminal is connected to node 2. This means that node 2 will be at higher potential than node 1. Hence, node 2 voltage and node 1 voltage, the difference between two potentials is 45 volt. Hence, let voltage at node 1 will be V1, voltage at node 2 will be V2, and voltage at node 3 will be V3. Then my supernode equation will be V2 minus V1 is equal to 45, which indicates that V2 is at higher potential because positive terminal is connected to V2. V1 is at lower potential because negative terminal is connected to V1, and the difference between two potentials is 45 volt, which indicates equation number 1. Now apply KCL to supernode 1 and 2. We will exclude this 45 volt portion and we will write down the equation for node 1 and node 2 simultaneously, considering other currents. Now if you observe node 1 and node 2, there are no incoming currents towards node 1 and node 2. Hence, incoming current at node 1 and node 2 is 0. Outgoing currents from node 1 and node 2 are I1, I2, I3 and I4. Hence, the equation KCL for supernode 1 and 2 will be by Ohm's law. I can write down the formula for I1, I2, I3, I4. I1 is the current flowing from node 1 to reference node. Hence, it can be written as V1 minus 20 minus 0, that is the potential of reference node, divided by 5 ohm. I2 is the current flowing from node 1 to node 3. Hence, it can be written as V1 minus V3 divided by 10. Then I3 is the current flowing from node 2 to node 3. Hence, it can be written as, and I4 is the current flowing from node 2 to node of reference through 120 volt battery. So, I4 can be written as V2 minus 120 minus 0 divided by 50. Now in I4 and I1, the 20 volt is written as minus because as we are going from node 1 to reference node, the battery terminal comes to be first positive then negative. Hence it is drop in potential. Hence, as per sign convention, it is written as minus 20. Similarly, for 120, the current is flowing from 2 to reference node. So, during this path, the first terminal is positive, second terminal is negative. Hence, that is drop in potential, and therefore, for sign convention, we have written it as minus 120. Substituting all these values of I1, I2, I3, I4, we get the equation . After solving this equation, we will get the reduced equation as which is equation number 2 as extended equation. We have two equations now for supernode, equation number 1 and equation number 2. Now we will apply KCL to remaining node, that is node 3. At node 3, incoming current is I2 and I3 towards node 3 and outgoing current is only I5. Hence, the equation will be I2 plus I3 is equal to I5. I2 and I3 are incoming current, I5 is outgoing current. Now by Ohm's law, we can substitute the values of I2, I3 and I5, which will be I2 is replaced as V1 minus V3 by 10. Then I3 will be replaced as V2 minus V3 by 20. And I5 will be current flowing from node 3 to reference node. Hence it is written as, after solving this equation, we will get equation as by solving these three equations 1, 2 and 3, we can calculate the values of V1, V2 and V3. V1 will get 21.89 volt, V2 we will get 66.89 volt and V3 will get 15.81 volt. Now we want to calculate current through 15 ohm resistance. So I 15 ohm, the current flowing through this 15 ohm resistance. This is the current to be calculated. The current flowing through 15 ohm resistance is I4, which is given by formula V2 minus 120 divided by 15. Substitute the value of V2, which we will get as minus 3.54 ampere, and the current direction shown is downward. The magnitude of the current is 3.54 ampere, and as we know, negative sign indicates the actual assumed direction is opposite to that of assumed direction. The actual answer will be I15 ohm is equal to 3.54 ampere, and the actual direction should be upward in this problem. Thank you for watching this video.